Another situation that comes up a lot in probability is known as drawing without replacement. This is when you draw items from a finite population and the drawn item is not replaced before you draw another one. So a classic math class example is something like where you have a bag of marbles where 5 of the marbles are red, 3 of them are blue, and 2 of them are green. And you draw 2 at random. And assuming you draw without replacement, that means that when you take a marble out, there's then fewer marbles left in the bag. So you need to take that into account when you calculate your probabilities. So the probability you get 2 red marbles, well, you're drawing 2, so it's a sequence again. You have a red and a red. So if you wrote this out, probability of red first and red second, you could calculate that. It's a sequence, so you're still going to multiply, except now the probability changes after the first one. So the first one, there's 5 out of 10 is the probability because there's 5 red out of 10 total. So, but then for the second one, you need to consider how many marbles are left in the bag. Well, there aren't 5 red anymore. There are only 4 red. And there are only a total of 9 marbles in the bag. So you do 4 divided by 9. So it ends up about 22.2%. You could similarly do the probability you draw no red marbles, probability of not red. And to do that, you do the same thing here. It's a sequence. So you're going to multiply 2 numbers together. Well, the probability the first one isn't red is 5 out of 10 because there's 5 that aren't red. And then the second one, it's 4 that aren't red out of 9 total. Oh, that works out the same. Maybe I should have used different numbers to make that more interesting, but same idea. Originally, there are 5 that aren't red out of 10 total, but after you take out one that's not red, there's 4 left that aren't red out of 9 total. 2 green marbles, probability of green, you do the same way. The first one, there's 2 green out of 10 total, and then multiply that by the second one, there's 1 green out of 9 total. So, oh, I'm really fixated on 2s today, subconsciously maybe, but you get 2.22%. You can do the same thing if you're drawing 3 at random. The probability they're all red, probability RRR. Here you just multiply 3 different things together because it's still a sequence. So 5 out of 10 for the first one, 4 out of 9 for the second. And then for the third one, there's 3 red marbles left out of 8 total in the bag, so you get 8.33%. Now the probability they're all green, you can answer this one a couple different ways. The first way would be to observe that there's only 2 green marbles in the bag, so 0, or as a decimal, 0.000. Let's format that as percentage, 0.00, easy enough. But if you actually want to calculate it and you really like fractions or something, well, the first one, there's 2 out of 10. The second one, there's 1 out of 9. And then for the third one, there's 0 out of 8. So again, you calculate that, but you get 0 as well. So I don't think you have any web work problems that involve drawing without replacement, but you'll probably see it at some point in the class. Where it comes up a lot is when you're dealing with card games, especially if you have a card game with a single deck of 52 cards. Once you draw cards out of that deck, the probabilities change for the remaining cards. And so if you're like someone who really likes watching World Series of Poker or something, or you're just playing gin or something with your friends, then drawing without replacement is very much the normal situation, not, you don't put the cards back and then deal with them. So it's really fun if you're playing a card game with your friends to sort of pause the game, do a bunch of really complex calculations, and then base your strategy on that. People love it. I really encourage you to try it.